So just to save us a little bit of time, I already went ahead and isolated this whole section of geometry from our main mug. So I just selected these faces and we have something like that. So go ahead and just isolate these faces if you haven't already. I'm now going to turn this into a VDB, so VDB from polygons. And while we're here, because I actually really haven't talked about VDBs, let me just give you a really brief overview of VDBs. VDBs are volumes, same thing as everything that you see whenever you have these volumes, but it's calculated in a way that's a lot faster to calculate. So whenever you can, you always want to use VDBs. There are two main flavors to it. We have this distance VDB, which is a signed distance field, and we have this fog VDB. The main difference here is that this distance VDB will basically put voxels along your surface, and the fog VDB will essentially fill this whole thing with a fog. So let's say 0.01 on this voxel size. That'll give us this resolution. There is a lot more to say about the distance VDB. That was a very poor SparkNotes version of that. But in general, just know that this is going to be faster for us because we're only concerned with the VDBs along the surface. You can actually see it's kind of hollowed out along here. Okay, anyway, we have that. Let's create a null. And if you've watched that cool little quick tip I did with the light bulb on how to make volume collisions, that's exactly what we're about to do. Static object. And I'm going to create a merge. If you're watching this on CGForge, I'll also include a link to that tutorial because it's pretty cool. Okay, static object. I put this up one notch so that the left input is affecting right inputs like that. Let's take this null that we just made, which is our collision. That's our SOP path. Let's also go to collisions and then down under the proxy volume section, feed that right in there. I'll set this division method to, or actually this mode here to volume sample like that. Let's turn off display geometry, turn on this collision guide, and now we can see our collision geometry like so. It's actually a lot more resolution than we need, so let's only use what we need. Let's try setting this to 0.05, and we probably actually need a little bit more than that. Let's try 0.04, and maybe one more, 0.03. It's always worth getting away with as little as possible for these collisions here, because it'll really speed it up. Okay, we have that, and then let's say this. Anything that reaches the bottom there will just get killed because of the bounds. Okay, great. We have our collisions. It's working, so we don't have that issue anymore. And it looks like it's spilling over right here, but it's not. So we're all good. Just to make sure. Yeah, okay. It's all just kind of staying within that container. You could see it right about there. Okay, cool. So there is our collisions. Again, more on that and what just happened there if you're not sure with that tutorial link that I've provided. Okay, there's our collisions. There is our smoke right now. It's already in a pretty decent spot, I'd say. The next thing that I'd like to do is create a little bit of disturbance within this density here. So I'd say probably the two main things that really will change the shape of something would be disturbance and turbulence. I just showed you turbulence. Let me now show you disturbance and what that does. Gas disturbance. Let's create a merge and merge this in with our turbulence like so. We want this, the combination of these two things, to become our velocity update. Let's also press L to lay everything out. And I'm going to hide these windows because we don't need it. Okay, so disturb. This is basically a way of adding breakup to some kind of field. It's kind of like adding a noise, but unlike turbulence, I think the disturb does a lot better job at capturing some fine details and just kind of adding a bunch of more of a pocketed kind of hole-looking effect, like kind of punching holes into the smoke. It's kind of the way I visualize disturbance. So it's basically just a different kind of noise that we're layering on top of whatever field we like. Okay, so on this disturb, let me start off by changing this bindings here. By default, this disturb field is temperature, but we can change this to whatever. Again, we have this threshold field, or I think of this as a mask field. This will tell the disturb where it should happen and where it should not happen. So for right now, I'm going to leave that at density, and let's just try disturbing our density as well. It's only going to happen where there's smoke, and we are disturbing the smoke. Also, under the Advanced tab, you can check OpenCL. And same with the turbulence. So if you're using OpenCL, you got to do that as well. Okay, back to disturb. Let's go to our visualize here, check density. I'm going to go to this density tab, and by default it says use smoke, but we can uncheck that and instead say use a plane. Now instead of infrared, we can also map this to, let's say, a grayscale preview, like that. And now we're just taking a cross section of our smoke. And as you can see, by default, it's really looking pretty weird. So let's see what's going on with that and why that's happening. First things first, let's turn off everything else as we dial in this gas disturb. Remember, we want to isolate everything that we're working on and then reintroduce things one at a time. So let's take everything else, bypass them, and we go forward a few frames. What you'll see is that, yes, it is in fact this gas disturbance that is causing the issue. And actually, everything is working the way it should. The thing that's tricky about this, that's different than the turbulence, is this cutoff right here works a bit differently. So this says, ignore voxels that are higher than this value. So if the density is higher than 0.1, ignore it. And anything that's below 0.1, that's what this gas disturb should affect. And right now, the voxels outside the smoke are 0, less than 0.1. That's why they're getting hit. And so we don't really want that. And so there's actually a different way we can control where this disturb happens. Let's say this. For the cutoff, I'm going to set this to a really high number, like 999 something. And what that will do is it'll basically force this disturbance to happen everywhere. So right now it's happening at all values, right? But now I can go to this control settings and I can use my own control field to mask this off in a very specific way. So this control field, let's specify density. Let's just roll with that whole density idea to mask off this thing. And let's also change this control influence to 1 so that this is taking a full effect. Now, if we go forward a few frames, you'll notice that our issue is gone. Let's also do this remap control field. That remap control field will basically say that as values reach 0, this left-hand side, right here, the gas disturb will not do anything. This is kind of like how much is the gas disturb going to work. On the left-hand side, we have 0. So once it reaches a value of 0 in density, nothing's going to happen. Once we reach this top value, which is 1, the gas disturb is on full effect. But this is, again, kind of, it's kind of difficult to see what we're actually doing because I have no idea what these density values are inside of this cutout plane. I mean, I could see there's some black and white values, but I don't really know what these values are. So let me show you a cool trick that will tell you what values are being stored in these voxels. Let's go to this pyro imports. That's where we're importing all of our final frames or our final volumes, right? And let's go ahead and go to our camera. Let's also go to our smoke sim and turn off this use plane so that we have our smoke. Okay, so there's our pyro imports. Let's do a volume visualization. There's our density right there. Looks like we don't have density. Let's plug this in right there. We're good to go. Now we got our density. There it is. Let's also use another node here called a volume slice. And this will basically just take a plane, it'll send it through the volume, and it will slice the volume like that and read the values and turn those voxels into points that we can read from. With this group, I'm going to specify density right there. We don't need infrared, but we can do a grayscale like so. And we also want to set this to points so that now we just have a bunch of points. And on these points, if we go to our geo spreadsheets, as you can see, we have density being read out, and our highest value is a value of 10. With this information in hand, let's now inform our disturb node what to do in the next video.